Thanks to my channel friend who requested this video. The video is talking about the manufacturing drawing needed for a control panel. Before we go into this control panel drawings, we need first to look at any drawing. Any drawing should have a border. The border consists of many items here, like the company name, address, and so on, and who had prepared the drawing, and who had checked it, and who had approved it, and most important, the stamp for the engineer who approved this drawing. Now the drawing should have a drawing number, sheets, and so on, and the revision. The revision, we need to make a lot of effort to understand what is the revisions are and what's the issue for. So if you are building a cabinet, you should build it from IFC, which is issued for construction, not anything else before that. If you're doing maintenance, don't do it maintenance on something like the issued for check. You do maintenance on a cabinet which is manufactured and built. So you may find issued for construction, or you may find as built drawing. Let's go into the first drawing. The first drawing is a list of all drawings for this cabinet. Now the list, if you are preparing the cabinet by yourself, like you doing the design for the cabinet, you may not have a good idea on how many drawings you will need, but you will need a legend, a dimensional drawing, internal, external layout, bill of material, wiring drawing. Now the wiring drawing could be 5, 6, or 10. So now it comes to the drawing number and how you will number your drawing to allow you to insert one drawing if you need one in the middle. Let's go through them one by one. So the first drawing is your drawing schedule or your drawing list. Second is you have to specify the legend and the abbreviations which you're going to use in your drawings. So second thing is that your legend and abbreviations are very crucial for your understanding your drawing. So if you look at this drawing, you can see here there is a black dot with a line in it, which like slash, which is to the left side, which is mean it's fused terminal. If it is on the left, it is a circuit breaker. Right is fused. Is open one, it's a disconnected terminal. Now all those and the panel wiring, and this is maybe field wiring, which is the dashed line, network drawing, network wiring, and the abbreviation like BK. This is the black and the white and the red and so on. So now you can have also in the legend is the footprint of your relays base at the terminal, how you're going to express them in your drawing, and so on. A lot of these items come from many sources, but assume you would like to know where you can get yours. If you are working for a company, you definitely will have access to all the sort of the symbols, but if you are would like to know more, then here is how you can do it. So where to start? It's easy, just to go to Google electric legend symbols and then put PDF, and that will bring you a lot of resources. The first one here is GOV, which means it's a government site, and then you can click on it. You download the drawing from this site. Now this is one site, but you will have a lot of sites also, company sites or organization sites or government sites. All of them will give you a lot of resources which will help you doing your cabinet, or checking other things if you would like to add or to do something. You can see here this is the American National Standard. Also it's available for download on the web. So you have a lot of resources you can actually enjoy from the website. Now the next drawing is a dimensional drawing. This could be one or more drawing. The idea is that you will specify the height and width and depth of your cabinet, but not only this, but also you can indicate how it will be supported or installed in the field or inside your e-room. Also, you're going to show how you're going to lift this cabinet from where, and also you're going to show all the connections, meaning where is your cable entry, the size of the cable entry, and also how many cables you're going to go through them. That's later on, but here you will show the cable entry only. Now, the cable entry, you could have it bottoms or top. That's sometimes the client will specify top entry or bottom entry. Now, one other item very important in the cabinet is to show the swing of your door. So if the door open, you may need to make sure, like if you are the client, you make sure that the cabinet, when it's open, there is enough clearance to the nearest wall or nearest another cabinet. But from the panel manufacturer or the cabinet manufacturer perspective, you need to specify if you need an access from the back of the cabinet or only access is from the front. Now, also you need to indicate the weight and the HVAC connection if there is anyone. The next drawing is the equipment layout. We have equipment maybe on the door or in only internal. So we're going to show the manufacturer what we're going to install in the front of the cabinet and also internally of where we're going to put them inside the cabinet. One item here, like say if you look at this cabinet, this is 1500 millimeter height. Now this cabinet will be, let's say 30 millimeter 300 millimeter of the ground. So now the top will be 1800 from the ground millimeter. Now if you have operating push buttons or HMI, you need to put them, let's say at minimum 150 centimeter from the ground level or 1500 millimeter up to, let's say 1600 or 1700. That is the maximum 1700 millimeter from the ground. So you will show the panel manufacturer where these things will be installed, and also you will show him what's the distance between all of these push buttons and selector switches. Now, internal cabinet layout, when you build a cabinet, you will tell the guy who's going to build it how you're going to lay all the internals. Also the wireway, the 120, the 24 volts, how you're going to separate both voltage, and the layout also will show where is your cable entry, and you will have to tell them everything about it. Now if you received a cabinet for review, you also need to check what is the clearance between your terminals and the raceway or the wireway. Now the wireway may be very close to this circuit breaker, but you have enough space for your wiring here. All the field wiring could be in this side, in that side, you have 24 volt and so on. Now during the layout, you have already had laid all your equipment, so you know here we have, let's say 12, 15, 18. 12 and 15 and 18 in the bill of material, we will explain what each one of them. The number 2 is the quantity we needed from this item. Also here, if you notice that the Lamacold is also indicated here, and we have another drawing will explain all the Lamacold. So next one would be the bill of material. So the bill of material will give him the reference from the layout drawing, and maybe this reference will be in the wiring. This is the reference would be in the layout drawing, and then you explain what is meant by this thing, and if the manufacturer and who is the part number also. So this, when you inspect the cabinet, you will look at all of these and you will see how many ground bar we have, how many cabinet, how many lights, and so on. What is the cabinet made of, 316, and so on. So that is one of the items. When you inspect a cabinet, you need to look at the bill of materials. Now if your bill of materials and layout is not too big, so you can accommodate them in one drawing, let's put them in one drawing, not two drawings. This will save you the issue and document control cycle for two drawings. So sometimes it saves you money because it saves you time, because it's only one drawing. Now if it is not, then you can put them in two drawing, or maybe the bill of material will be in 3 drawing or 4 drawing, depending on how big is your cabinet. Lamacold and label lists. Now you will have one specific drawing only for Lamacold, and the label list, and you will specify, let's say, the warning, what kind of warning. The color of Lamacold is red, the letter is white, and line 1, line 2, line 3, and so on. And then you will give him the dimension. So either you give it to the panel manufacturer, all this list, or you give them the list of your stuff and ask them to give you the size and their recommendation. So it depends on what you would like. As we have seen before, 22 was a white color, the background, and the letter was black, and it says motor X M1234, and the size is 5 centimeter by 3 centimeter. Now we'll go into the more important thing, which is the wiring. This drawing, you can see there is two things in this drawing. This drawing shows the field wiring. The field wiring is not in the cabinet manufacturing thing, because that's field wiring. So the TB, the details, you may, if you are the panel designer, you may produce this one, because you will give it to the field guys to erect on, lay on those cables and connect them. For the panel manufacturer, you will not use them, but you need them because you need to know which signal lands on which terminals. Now, the other thing I would like to mention in this drawing is this connection. This connection will later on we'll talk about it, but just keep it in mind. The second wiring, we will start with the wiring. When we look at the wiring, let's start with some kind of logic. So we will start with, let's say, the high voltage, the motor connections first, and then we'll go to the power distribution, or in the beginning the power distribution, the 600 volt in this case, or the 120, and then 24 volt. So first you do the power distribution, and then you go into the I/O and the control. So in this case we have 3 or 4 motors. We have the contactors. It's 2 direction motors. You have the contactors here, the main circuit breaker, the fuses, the overloads, and it indicates what is your field side and your panel side. Now the power distribution, we'll see a couple of drawing which shows different style, but this is one of them. We have the 120 coming here, and then the main circuit breaker, and from the main circuit breaker we have distribution to all of these, and then we have some indicator here, and this is our neutral. If you notice here, we have a terminal. So each one of these, they land on a terminal on the neutral, and the wire from the circuit breaker goes direct to each one of those indicators. Now this is another way you can show it. I mean, you can use whatever you like, which is explains how the guy who will build the cabinet will build it. In this drawing here, we show the circuit breaker for supplying the PLCs, let's say base 1, base 2, base 3, and so on. So you have 2 supplies, 2 feeds, because it's a redundant system, and then it shows each one how you connect it for each one. So the main benefit from this drawing than the one we have seen is you see now is the actual layout of your PLC, and you know exactly where you're going to connect it. So physically, you know this is 1, 2, 3, the 4th screw from bottom. I'm going to connect it here. Again, your neutral is separated, and this is one way of showing the drawing. Again, maybe it's a little bit hard to draw, like it will consume more time than the previous one, but it's for the guy who is going to do the panel. It's maybe it will give him a little bit of more information. Again, you can show the circuit breaker as a circuit breakers, or you can show it as the symbol as we have seen it in the previous drawing. Again, the 24 volt, you can do whatever you like. You feel it's easy for you to do, and it's easy for the guy who's building the cabinet and for maintenance later on. Now you can see here in this terminals, we have a supply, the 24 volt. This is a 2-tier or 2 levels terminals, and we connect the power, the 24 volts to this one, and then the return will go somewhere, and so on. So again, it depends on the method the company used. You will produce your drawing. Let's look at this drawing. It shows that F7 is supplying to the common of all those relays. From relay 1, then you go to between 2 to 23, and then you connect it up to 24, and then you jump to 193, and then jump to 201. So this is one way of showing it. So again, it's the easy for the panel manufacturer or the guy who's doing it. He knows now that 9 at the bottom of the cabinet, so he knows where this wire will come from the base. That's the bottom of the base, so he will know how he will run the wire. But it saves him a little bit of time. Now here again, in this example we have multiple relays. Any one of them energized will turn this lamp on. So in this method of drawing, we can see that we know that's the from terminal 8 from each one of those relays goes to this lamp. So now we will draw it with a different method. So F7, this is fuse 7, which is 2 amps connected to 12 in R2, 12 in R6, 12 in R22, and so on. And then I take 8, which is the normally open contact from this relays, up to L52. So now you can see, now you can appreciate that this drawing is much easier than this drawing, of course. For the guy who is doing the cabinet manufacturing, he will have to go into each base, and once he knows that 12 is here, it's the bottom left terminal, so he knows now where he can connect it. So either way, it will be okay if you go with any one of those methods, but normally, or 99%, you will find this method of drawing. And this, now we finished the power distribution. Let's go into, let's say, in the control. This is a method, one way of doing the control. You show each terminal here. This is a fuse 4, and the 4 amps. So now when I look at this drawing, I know exactly where this fuse is. That's in TB1, and this is fuse 3, fuse 4, and I can see what is the amps rating of each one of those fuses. Now if you go into, this is the overload 1-1, that's mean the first contact in overload 1, and you have the number of your terminal and so on. Now this dash lines means it is not in the cabinet, it is field mounted equipment. So you will know that this is your terminal in the cabinet and this is the field. So now the field wiring, you need a separate drawing which only shows those TBs, TB1, 2, 2, and so on, which is field wiring. So the TB for the field wiring, he should not go into this and figure out what's going on. So it's a separate drawing for the field wiring. Now let's jump to the PLC. Now PLCs, we can draw the PLC connection in many ways. This is one method of them. So this is all DOs. So it's PLC 1, base 1, the card number 7, and channel 0. Channel 0 will go into the output from channel 0 to A1 in the relay 1, and so on. And then if you notice here, the common for A2 of all the relays is jumper to each. So you jump from TB, whatever TB, number 20 to the first relay, and then from the first relay to the second, and so on. In the second drawing, you can see that A2 goes to terminal 21, A2 goes to terminal 22. Now this is the full I/O card. You got all the output here. Now this is your card power supply. You may show this, you go into another different drawing to see the I/O supply, power supply. Here is, I show how the power supply is connected. So you got the fuses, you got all the terminals. So this is one method of showing it, but you can do whatever you like. As I said, you can see in this card here, you got two common supply for this card. So I go from this card, this fuse to all those cards here. Now this is another method of how I'm going to show the connection for the PLC. The method here is a little bit different because it's a redundant system, but still you can do the previous one exactly the same. You can see here that T0 and T0 are connected to relay 45. So I showed only the first one, so he knows physically where is my connections, and then I gave him a table which is say the relay 49A2 will be connected to this PLC1 channel, so and so, or card 4 T0, card 4 T1, and so on. So this is one method, but be careful when you do a drawing like this. Notice how I connect here that drawing, this wire and this wire. It looks, you don't know if you go from this to this and then one wire to the relay, or the other way around, or you connect them in the middle in the wire way, and then you go here. Now look at this drawing. It clearly said from this terminal go to the relay, from this terminal go to the same relay. So they will be connected in this relay. Here I added the word black, so you know now it's a black wire. If you have a digital input, it will be exactly the same. This is my digital input. This is field wiring, and this is the supply for the let's say the 24 volt or 120 goes to the contact in the field and come back from the contact to your card here. Now you need a special drawing for your special equipment. So assuming you have, let's say, indicator which has a special method for connection, you can include it in one drawing. Maybe you have a special instruction for the grounding and so on. So maybe you need a special drawing for these ones. The next wiring drawing is a network drawing. Now the network drawing, you will show, let's say, PLC1, PLC2 are connected to the network switch, and in each network switch, each cable of these, you will specify the color of the PLC, the color of the cable, and you will indicate on the cable to from. Now let's talk about a wire tag. What is a wire tag? It is the small thing which is we have the wire name plate or name on it. When you take a wire from a terminal, you need to put it back in that terminal, so you don't confuse and put it in a different terminal. So this is the main idea of the wire tag, why we need it. Now you have here two methods. The first one is to from. So in the TB1 terminal 5, the wire coming out, I put here a black, so the color is black, and here I say TB1-5 and /R1A1. That's mean from TB1-5, and it will go into relay 1 terminal A1. In the relay, you put a wire tag again. It says R1-A1, which is this terminal, /TB1-5. So you know exactly where it will land on the other side. This is one method of it. Now, if you look at A2, it goes into a terminal 8. Let's look at the second example here. Now, you got the wire gray, and it says only one thing, it's 5. That's mean if you take this wire out of the terminal and you take this wire out of the terminal, you will easily put them in their correct places. Now it doesn't show you where it goes, but just say 5. And here it say R1A1. And here it goes to N. It doesn't specify which terminal. That's bring us to a different methods of panel manufacturing. The machinery panels, most of the time, I said most of the time, but not everyone. they put, let's say, LLL. That means this is the live terminals. You can take any one of them and use it in the cabinet, and this is the end. So you can land it in any one of them. But in the industrial panel, which is not machinery, so we normally put the terminals with numbering, and we say this is the 120 volt AC from 1 to 5, and then the neutral from 6 to 8. So the wire tag needs to be specified how you would like to show it in your drawing. So the guy who building the cabinet will just follow your instruction. The next drawing is the equipment setting. You may argue that you don't need it or you need it. You may list all the fuses, the circuit breakers, alarms, overload setting, network setting, dip switch setting. Don't forget that this drawing is not only for the cabinet manufacturing, but it will live as long as this cabinet lives and works. So it will be used for the maintenance as well. So now we will look at some notes. The first one is you need from the beginning to think about the drawing. How are you going to make a drawing number? So you have one drawing per cabinet, and then you need to put sheets, sheet 1, sheet 2, sheet 3, and so on. Or you will put a multi-drawing number. So you will put, let's say, dimension drawing will have one drawing number. A bill of material, another drawing number. And then in the wiring, you have one drawing number or two drawing numbers, one for, let's say, for the motors, one for the 24, and one for the PLC. And then within the PLC, you will have some sheets, sheet 1, sheet 2, sheet 3. So this is how you're going to number your drawing. Now, you need also to sort them. So you need to sort them by, let's say, function. As we said, the power distribution, then the power distribution 120, and then 24, and then the I/O cards, the output cards, the input cards, the analog cards, and so on. So think about it from the beginning, so you will be easily add or delete one drawing if you would like. When you do the drawing, think about who is going to use the drawing. The guy who's doing the drawing, the first one will use it as a panel built at the manufacturing. The second one is the guy who's going to test it. So you will have to highlight each wire you're going to check in the panel manufacturing site. And then in the field maintenance, so some of the drawing is easy for maintenance, but it's hard to the panel build. So the other way around, so some drawing will be very easy for the guy who's building the cabinet or testing the cabinet, but will be very hard to do the maintenance. So think about those guys when you do your design. Combine or separate drawing. So you may include some bill of material with the layout, as we said, or the power distribution plus I/O. So it depends again how big is the content of each drawing. Now, this is something fundamental, is don't show each terminal on two different drawings. So the problem with, if you have a drawing, show one terminal and the same drawing connection will be shown in another drawing, when you do the test, it will be very hard because you will highlight it in one drawing and then you miss something, you may miss something. So try to do each connection in one drawing, on one drawing. And then if you need to go to another drawing, you may say see drawing so for continuation, right? So that will be easy for the guy who's doing the maintenance and for the guy who's building the cabinet as well. Let's look at some pictures. Maybe we will explain. In this cabinet, this is an SIS cabinet. When you find all the power distribution on the left, and then your SI system in the middle, and we have maybe the communication on the right or something like that. So one good thing about it is that you have all your 120 supply on one side. So in all this side is, let's say this is the I/O and your controller and things. So this is one way of doing it. Don't forget that you have the ground. The grounding, normally when we talk about industrial cabinet, we talk about two grounds. One of them we call dirty ground, or the 120 ground, electric ground, and then we talk about the instrument ground, which should be separate. Don't combine them in the cabinet. They should be two separate grounds, and then you connect them outside the cabinet. We prefer to connect them outside the cabinet when they connected in the control room. All the ground from the instrument and all the ground from the electric, we connect them there. Some codes or some companies, they allow you to connect it inside each cabinet, but at the bottom here. So you connect them here and then you go one connection. So check, especially for your DCS or PLCs, check what is the code you are following and the manufacturer recommendation. If you can see here, we have this cabinet. During testing, we have a lot of cables, because when we did the testing, we connected to a cabinet with all the I/O, so we can simulate the compressor or the turbine which is running, and we make sure that everything is going right. The only thing which is I showed to you here, because you look at the distance between the terminals and the space allowed here for the wire for the cabinet, because that's something which is specifically for maintenance guy would be it's easy or hard to do the maintenance for the cabinet. Main supply goes through circuit breaker, distribution, again to all my fuses. This is my 600 volt and these are my contactor down. All my contactor are connected to the overloads, and they will go to the output. My motors here will connect only for the motor in this side. So this is 600 volt connection. It's completely separate than my 24 volt connections. You can see here, as we said before, the distance between the terminals here and the wireway is very small, so it's very tough for those guys, but later on it's here, you can see it's okay. We don't have any issues later on. So again, the problem would be if you increase it, you may go over the size of the cabinet too much. So sometimes you play with these things. You can see here we have one common connecting all the terminal. Those assume I'm not quite sure if it's 24 or 120, maybe it's 120, and then we connect them all here, so you don't have any connection between the terminals. Colors is shown in this lamps. You have white and black, so unless you specify to the guy who's building the cabinet what is wiring color you're going to use, he may use something different. This is an actual case when we already placed an order to a turbine manufacturer, one of those great turbine manufacturers, and we gave them an order of more than $20 million of cabinets and turbines, but their standard is to use all wire inside the cabinet as gray, so they don't use black and white. Maybe only for the 24 volt power supply is red and black, but all the other cabinet wiring should be gray. If you try to change them, they will not deviate from that, because they have not only your cabinet, but they have a standard cabinet. They build it for many turbines, and they are responsible for the maintenance of the turbine. So they send their technician. When the technician goes to the cabinet, he expects to see a specific items at specific places with a specific color. So they refused completely to change any wire color. Just to give you an idea. Another cabinet here, we can see that the PLCs, and you can see the battery here, a backup battery for your UPS. So if something happened, obviously if you lose the power to the cabinet, you lose the power to the equipment. So I cannot run my motor, but you need to keep the communication with the DCS, let's say. So in this case, I need my PLC to be able to do specific items, like this is a safety PLC, and it has to be connected with the PLC all the time, so with the DCS all the time, and also to do a specific tasks when the power is gone. Here you can see, as I told you before, it depends on the manufacturing standard. This guy, they use gray, and for all the A connections, B connection is red, and then the C connection is black, and it doesn't say to from, it just say A1, A2, A3 and so on, and then terminal 1, terminal 2, so you know where you're going to connect it. If you take all of those wires out, you can put them back again. 120, most of the time we ask the guy who building the cabinet to have a flex glass, a plastic glass on the 120, so no one will accidentally put their hand and get a nasty shock. This disconnect terminals, so just show you that we have plenty of space here and it's very nice, and we have also all the wiring shield should be connected here. So all of these, let's say if this is 420 milliamps or analog input, we cannot connect our shield, the cable shield, in this connections here. So that will save space in my cabinet. But the terminal is all the terminals are actually elevated a little bit, so they will not interact with your ground. And the other thing is that this will save a lot of space for your cabinet. Thank you for watching, and if you are not subscribed to the channel, please subscribe. And if you have a specific topic you would like us to talk about or discuss, please let me know. Thank you, and see you in the new video.